At 1401 UTC on June 6, 2026, active region 4461 on the surface of the Sun released an M1, 8 solar flare, and with it came something that changes the calculation for the next 48 hours entirely. A filament eruption producing a partial halo coronal mass, ejection traveling at an estimated 838 kilometers per second, directly toward Earth, now confirmed by NOAA's Space Weather Prediction Center to arrive at our planet's magnetic field around midday UTC on June 8th. With isolated G3 level geomagnetic storm conditions already forecast for Monday, and a G3 watch formally issued by SWPC as of this morning, June 7th, 2026. That CME is in transit right now. The distance between us and what was just launched from the Sun is closing at a speed no human language was built to fully hold, and the instruments are watching every second of it. If you rely on this channel for science, grounded and verified data, and explained with honesty, subscribing ensures none of this reaches you late. This work depends on the audience that values it. Every figure in this account was drawn from official scientific and governmental sources: NOAA's Space Weather Prediction Center, NASA's Solar Dynamics Observatory, the SWPC 3-day forecast issued this morning, and peer-reviewed space weather research. But official sources are not infallible, and neither is the human process of reading them. Before any decision is made, whether personal, professional, or otherwise, verify independently through the official channels. The sources are listed. The data is public. The responsibility to check belongs to all of us. But that is not even the complete picture, because what the instruments are detecting right now on June 7th, 2026 is not a single isolated discharge from one restless region on a quiet sun. What is actually unfolding above this planet's atmosphere is the convergence of multiple solar events. A cannibal coronal mass ejection that struck Earth's magnetic field at 4:30 UTC this very morning, an M1. 8 flare and filament eruption launched at 1401 UTC yesterday from active region 4461, a region still evolving, still gaining sunspot complexity, with neighboring active regions 4456 and 4462, both showing continued development on the solar disk, and behind all of it, a sun in the late and most energetically volatile phase of solar cycle 25, a cycle that has already proven to be more active than the forecasts that preceded it predicted. The question is not whether what is approaching is significant. The question is exactly how significant and what will be standing or not standing when the answer arrives. To understand what a G3 geomagnetic storm actually is, you need to move past the letter and the number and translate them into what they represent in physical terms for a civilization that has built its entire infrastructure on the assumption that the electromagnetic environment surrounding this planet will remain stable. NOAA's geomagnetic storm scale runs from G1, which is minor, to G5, which is extreme. G3 is strong, 2 full levels below the maximum. And here is where this account becomes genuinely significant. Because 2 levels below maximum on a planetary electromagnetic scale is not a cushion. It is a warning that carries documented consequences that power grid operators, satellite controllers, and aviation authorities are trained to take seriously before the event, not after it. At G3 intensity, according to NOAA's own published impact assessments, voltage corrections become necessary on power systems. High-latitude power systems may experience false alarms on their protective devices. Spacecraft in low Earth orbit experience increased atmospheric drag as the upper atmosphere expands in response to the energy injection. Satellite navigation systems, including the GPS signals that guide aircraft, emergency vehicles, and precision agriculture, experience intermittent errors that degrade their accuracy in ways the users at the end of that signal chain may not even realize are happening. And HF radio communications, the communications layer that maritime vessels, remote operations, and aviation use when nothing else is available, face potential disruptions across large geographic areas. The CME now in transit, the one launched at 838 kilometers per second from active region 4461 yesterday afternoon, will need roughly 48 hours to complete the 150 million kilometer journey from the Sun's surface to Earth's magnetic boundary, the magnetopause. Space Weather Live's 3-day KP forecast issued this morning shows the greatest expected 3-hour KP index for the June 7th through June 9th window reaching 7, which corresponds precisely to G3 on the NOAA scale, with the peak window falling between 18R and 21R UTC on June 8th, Monday. That is not a guess. That is the output of NOAA's modeling systems, running on the trajectory and velocity data pulled from LASCO C2 coronagraph imagery, the same instrument suite that has been tracking coronal mass ejections since 1995, and whose data forms the operational backbone of every serious space weather forecast issued on this planet. The filament eruption that accompanied the M1, 8 flare on June 6th, deserves particular attention because filament eruptions are not simply decorative features of a solar event. A solar filament is a structure of dense, relatively cool plasma suspended in the solar corona by magnetic fields. Magnetic fields that, when they destabilize, do not simply release their energy quietly. They release it as a coherent magnetic structure embedded within the CME itself. A structure that, if its internal magnetic field orientation happens to be directed southward when it reaches Earth, a configuration scientists call southward BZ, will connect directly to Earth's own magnetic field through a process called magnetic reconnection, effectively tearing open the planet's natural electromagnetic shield and allowing solar wind plasma to pour into the magnetosphere at a rate that drives geomagnetic storms to their maximum intensity. The filament that erupted from active region 4461 was approximately 11 solar degrees in length, 11 degrees on a body whose diameter is 39 million kilometers, and it was centered near solar coordinates S25E28. That is not a limb event, but that is a disk center adjacent event, which is precisely the geometry that maximizes Earth-directed energy delivery. This is not a hypothesis. This is documented in the orbital mechanics and magnetic field geometry that space weather forecasters have been refining for decades. The KP index forecast of 7 for Monday evening is a modeling output that reflects the trajectory, the velocity, and the partial halo CME geometry that the coronagraph imagery confirmed. And here is where the language of forecasters becomes itself the most important data point. NOAA has issued a watch, not merely an advisory. A watch, in SWPC terminology, means the agency has sufficient confidence in the modeling to formally alert power grid operators, satellite controllers, airlines, and high-latitude emergency services that they need to be ready. A watch is not a possibility statement, it is an operational notification. And here is where the history of this planet's relationship with solar storms stops being background material and becomes the floor shifting beneath everything you thought you understood about this event. On May 10, 2024, the Sun produced what became the most powerful geomagnetic storm since the Halloween storms of 2003. Active region 136664 fired an X8, 7-class flare, nearly 5 times more energetically classified than the M1-8 that launched this week's CME, and the resulting geomagnetic storm reached G5, the absolute maximum on NOAA's scale. The KP index peaked at 9. The DST index, which measures the energy injection into Earth's ring current, reached negative 412 nanotesla, a number so far from baseline that it places the May 2024 storm in the same historical tier as events that predate the space age. Solar wind speed during that event reached 750 to 950 kilometers per second. The interplanetary magnetic field reached a magnitude of 73 nanotesla, with the southward component reaching negative 50 nanotesla, which is precisely the southward BZ configuration that opens Earth's magnetic shield. The northern lights were visible as far south as Alabama. Power grid operators across North America and Europe scrambled to implement protective switching sequences, and that was a G5 event. The approaching storm is forecast at G3, that is 2 full levels lower. But the critical lesson the May 2024 event teaches is not about its own magnitude. The lesson is what it revealed about the vulnerability of infrastructure that was never designed with the assumption that the sun would behave the way the sun, in the late phase of a vigorous solar cycle, actually behaves. The lesson is that grid operators and satellite managers who had the May 2024 event happen to them on a day they were not fully prepared, and some were not, learned from it under operational stress rather than during a calm briefing room exercise. The systems, now watching June 8's approaching CME, were calibrated in part by what happened on May 10, 2024. But calibration and immunity are not the same thing. There are people alive today in Tromsø, Norway, a city of approximately 77,000 people sitting at 69, 6 degrees north latitude, well inside the auroral oval where geomagnetic storm effects are felt first and most severely. Who remember the May 2024 event because the northern lights burned so brilliantly overhead that the harbor turned colors? Those same people, if they have access to the SWPC forecast issued this morning, now know that the sky above them on Monday evening, June 8th, has a formally documented probability of reaching G3 storm conditions that will push the auroral oval southward, bring spectacular atmospheric light shows across Scandinavia, Iceland, Canada, and the northern United States, and simultaneously stress the same power systems that serve hospitals, water treatment facilities, and emergency communications networks throughout the high-latitude world. The beauty and the danger are the same event. They always have been. Consider also what is happening in the context of the broader solar environment right now, on June 7th, as this script is being compiled. The cannibal CME that struck Earth's magnetopause at 4:30 UTC this morning, the one that NOAA confirmed reached G2 storm levels, was itself not a minor event. A cannibal CME is the product of a faster CME launched from the Sun overtaking a slower one already in transit, merging with it, and arriving at Earth as a combined magnetically complex structure that is significantly harder to forecast than a standard single ejection event. The fact that Earth's magnetosphere absorbed that cannibal CME this morning and is now being asked to process the arriving front-runner shock of the June 6th CME on top of the residual disturbance means the magnetosphere is being stressed in sequence, not in isolation. The geomagnetic field is not at baseline right now. It is already elevated. And an already elevated system receiving a new significant injection of energy behaves differently, more unpredictably, than a system receiving the same injection from a fully recovered baseline. This connects to a broader truth about how Earth's electromagnetic environment functions that the framing of any single storm event tends to obscure. Earth's magnetosphere, ionosphere, and upper atmosphere are not a static shield waiting passively to absorb what the Sun sends. They are a dynamic, coupled system. When the magnetosphere is compressed by elevated solar wind pressure, it transmits that energy into the ionosphere through field-aligned currents. Currents that, at G3 levels, can measure hundreds of thousands of amperes flowing through the upper atmosphere in auroral latitudes. Those currents induce voltages in any long conductor on the ground directly beneath them. That includes power transmission lines. That includes oil and gas pipelines. That includes undersea communication cables. The induced current is not selective. It follows the path of least resistance through whatever conducting infrastructure happens to lie in its path. And at G3 intensity, the gradients are significant enough that protective relay systems on power grids may interpret the geomagnetically induced current as a fault condition and trip unnecessarily. Removing generation capacity from the grid at exactly the moment the grid is already under stress from the operational adjustments the storm requires. This is not a theoretical failure mode. It is a documented failure mode with a history. The Quebec power outage of March 1989 resulted from a G5 level geomagnetic storm that drove geomagnetically induced currents through the Hydro-Quebec power system so quickly. The entire cascade from first disturbance to complete grid collapse took 92 seconds. That human operators had no time to intervene. More than 6 million people lost power for up to 9 hours in a March blackout that represents, to this day, one of the most studied case studies in grid vulnerability research. Quebec, in March of 1989, is the historical anchor point that every power grid operator on Earth uses when they model what a severe space weather event would mean for their system. The approaching G3 storm is a level below what hit Quebec in 1989. But the infrastructure serving the populations now in the potential impact zone is more extensive, more interconnected, and more dependent on the precision functioning of electronic components than anything that existed in 1989. Which means the vulnerability profile is not simply a scaled version of 1989, it is a different calculation entirely. Think about the approximately 4 million people living across the greater Toronto metropolitan area, or the 3. 8 million people in the Oslo-Stockholm corridor, or the 5. 2 million people across the broader Helsinki to Murmansk geographic band, all of whom live inside or adjacent to the latitude zones where G3 geomagnetic storm effects are felt most directly. None of those people going about the ordinary weight of their Monday morning, the school runs and the commutes and the hospital appointments and the flights, have been given a reason to think about what is currently traveling toward their planet's magnetic field at 838 kilometers per second. And this is not a criticism of those people. It is an observation about the asymmetry between the speed at which nature operates and the speed at which human awareness moves. The CME does not pause for the population's attention. The solar activity driving this event is connected, as the verified science demands it be connected, to broader patterns that extend well beyond the immediate space weather picture. Solar cycle 25, the current solar cycle, which began at its minimum in December 2019, was forecast by the Solar Cycle 25, a prediction panel jointly convened by NASA and NOAA to be a moderate cycle, comparable in amplitude to the relatively quiet Solar Cycle 24 that preceded it. That prediction has already been decisively contradicted by the observed activity, including a solar maximum that arrived earlier and more energetically than the official forecast anticipated. The Sun is, in the language that scientists choose carefully when they want to be honest about uncertainty, behaving above the prediction envelope. And a Sun behaving above the prediction envelope in the late and most active phase of its 11-year cycle, the phase we are in right now, does not behave above that envelope uniformly. It behaves above it in bursts. It accumulates magnetic complexity in active regions that then discharge it in events exactly like the one that launched the current CME from region 4461 at 838 kilometers per second yesterday afternoon. The system is not inactive. It is accumulating. And this brings the account to where it must ultimately arrive, which is the boundary between what the instruments can measure and what they cannot predict. NOAA's Space Weather Prediction Center can model the transit time of a CME with meaningful accuracy, It can forecast the probability of G3 conditions with enough confidence to issue a formal watch. What it cannot do, what no instrument on Earth or in orbit can currently do, is determine in advance the precise magnetic field orientation of the CME's internal structure when it arrives. The southward BZ problem, as space weather scientists call it, is the central unsolved forecasting challenge in this field. A CME with a northward BZ when it arrives will interact with Earth's magnetosphere in a relatively benign way. A CME with a southward BZ will drive the geomagnetic storm to its maximum achievable intensity. The difference between a G2 event and a G4 event, between inconvenience and infrastructure stress, can depend on a magnetic field orientation that cannot be reliably predicted until the CME arrives at the L1 Lagrange point, approximately 5 million kilometers from Earth, roughly 15 to 60 minutes before impact. That is the lead time the instruments provide, 15 minutes. And for a power grid, 15 minutes is not a comfortable operational window. It is a crisis response window. The question is not whether the sun will one day produce an event that tests the limits of what modern infrastructure can absorb. The geological record, the satellite record, and the historical power outage record all point in the same direction. The question the instruments cannot answer, not today, not with the monitoring systems currently deployed, is exactly when the test will reach a scale the system cannot pass. The approaching G3 storm on June 8th may resolve as a spectacular auroral display and a manageable operational adjustment for grid operators who received sufficient warning. The SWPC watch system is precisely designed to provide that warning. But the same filament geometry, the same CME velocity, the same active region complexity now visible on the solar disk will not produce the same outcome every time. On June 7th, 2026, at the moment this script was compiled, active region 4461, the region that fired yesterday's M1, 8 flare and launched the approaching CME, was still positioned on the solar disk. It was still evolving. SWPC confirmed that neighboring region 4456 had produced a C8, 8 flare, and continued to develop, gaining additional sunspots with an asymmetric penumbra and a weak delta magnetic signature in its intermediate area. A magnetic configuration that space weather scientists specifically flag because delta-configured sunspot groups carry the highest eruption potential of any solar surface structure. New spots had also formed north of region 4462, multiple active regions, continued evolution. A sun that, on the instrument record of June 7th, 2026, shows no sign of settling. There is an old light in the sky above every city on this planet that has been there since before there were cities, before there were instruments to measure it, before there were power grids to be disrupted by it. That light is not passive. It generates, on average, enough energy in a single second to power all of human civilization for approximately 500,000 years. It expels mass in events that travel the distance between Earth and the Moon in under 7 minutes. And on the morning of June 7th, 2026, it sent a new pulse of that mass toward this planet at 838 kilometers per second. And the instruments confirmed it, and the watch was issued, and the G3 conditions are expected on Monday, and the magnetosphere that has protected life on this world for 4. 5 billion years is about to be tested again, as it has been tested thousands of times before, as it will be tested thousands of times more, whether or not any human being alive today has been given adequate reason to look up.